Welcome back, children. This is miscellaneous exercise 13th problem we are going to solve. Find the equation of the plane passing through the point and perpendicular to each of the planes. Our plane is there. Imagine this is our plane. Our plane passes through -1, 3, 2 a point, and then perpendicular to each of the planes. Our plane is perpendicular, so there are two planes, other planes. So our plane is perpendicular to these two planes. Can you see this? This is 90 degree and this is 90. So they are perpendicular. Now what you should understand is one point is there. We need normals. Now imagine I am drawing normal of this plane, the normal of this plane and normal of this plane. Okay. Now what is the normal of our plane is looking like? These two normals are perpendicular, so the direction should be the same. So you take any one plane's normal, because we know that they are parallel. Now think about our normal. You draw your plane's normal. Now what you observe? Your plane's normal and the plane's normal are perpendicular. Can you see that? Or you can say, very simple words, you can say that the normal of the given planes, you can say that very easily you can complete. Normal of these two planes are parallel to the plane. Do you agree with me? This normal is parallel, this normal is also parallel. So I can take this as a directions for my plane. Let me do that. So the vector equation, I am going to show both vector equation and Cartesian equation. Vector equation of the plane can be written as R vector equals, the point is A vector, plus, and we know these two normals are parallel to us, so we can write it as lambda into B vector plus mu into C vector. Here where B vector and C vector are the normals of these two planes. That's all. So R vector equals, A vector is -1 3j. Write it in the vector form, -i cap plus 3j cap plus 2k cap plus lambda into the direction of this xyz has to be changed to ijk. So you will write I cap plus 2j cap plus 3k cap plus mu into, again xyz, change it to ijk. So 3i plus 3j plus k. This is a equation of the plane, vector equation. Now we'll go for Cartesian equation. Cartesian equation of the required plane is we have one point and two vectors. So we go for x minus x1, y minus y1, z minus z1, and the direction ratio of this one you take it as a1, b1, c1. The direction ratio of the second plane a2, b2, c2 equals 0. This will give the Cartesian of the plane passing through a point and parallel to two normals. Okay, I hope you understood this diagram. Now determinant of x minus x1, y1, z1 is a given point. So x minus of -1 is +1. Then y minus 3, z minus 2. This is x1, y1, z1. Now directions a1, b1, c1. Direction ratios 1, 2 and 3. So 1, 2 and 3. Next, direction ratio of the second line 3, 3, 1. 3, 3, 1 equals 0. If only the equation is given, you can go for either vector equation or Cartesian equation. Cartesian equation generally it is easier because you don't have ijk, whereas vector equation you have to deal with ijk. Okay, let us find the determinant. Here I am showing both the equations. So 2 minus 9 minus y minus 3 equals 1 minus 9 plus z minus 2, 3 minus 6 equals 0. Let us check. X plus 1, 2 minus 9 minus y minus 3, 1 minus 9 plus z minus 2, 3 minus 6. Okay, let us start. Minus 7. Minus 7x minus 7. This is minus 8. Minus to minus, so plus 8. plus 8y minus 24. This is minus 3. So minus 3z plus 6 equals 0. We continue. Minus 7x plus 8y minus 3z. You have minus 24 minus 7 minus 31. Minus 31 plus 6 is minus 25 equals 0. So x cannot be negative. Change all the signs. 7x minus 8y plus 3z plus 25 equals 0. This is the easy way of doing it. Thank you, children.